Too crazy.
I think it's too far. Although,
for now,
it is true that the laws of physics do not prevent that. So, relativity, I teach relativity at Manchester University, right? To the first years, the 18-year-olds. And the first thing we do in special relativity is talk about the fact that if you travel close to the speed of light, so if you had a spacecraft traveling close to the speed of light, then distances shrink from your perspective. So, and the one number I always have in my mind is at the Large Hadron Collider at CERN, the protons go around the ring, which is 27 kilometers in circumference, and they go around at 99.999999% the speed of light. So close to the speed of light. At that speed, distances shrink by a factor of 7,000. And so that ring is something like 4 meters in diameter to the protons.
Whoa.
So according to laws of physics, if you can build a spacecraft that goes very close to the speed of light, you can shrink the distance to the Andromeda Galaxy, and therefore the time it takes to get there, by an arbitrary amount, actually. The closer you get to the speed of light, the more you can shrink it. And so you can make those 2 million light years. You could traverse across that distance in principle in a minute, according to physics. However, the downside is that you couldn't come back to tell, if you came back to the Earth at that speed to tell everybody what you'd found, at least 4 million years would have passed on the Earth.
Oh boy.
So you can't. So there's kind of a downside to it, that we could, in principle, explore the galaxy and beyond, but getting to chat to everybody about what you found is forbidden.
Wow.
By the structure of the universe, just the way that relativity works.
That really is essentially a time machine.
Well, it's a time machine in the sense that we could go arbitrarily far into the future by flying around in a rocket very close to the speed of light. So we could come back a million years in the future and look at the Earth and find out what had happened. You can't go back as far as we can tell. So you can't get back to you can't build a time machine to go backwards. So these are time machines. The world is built. Someone goes close to the speed of light, or someone goes near a black hole or something where the space-time is all distorted. Then you can get big effects. But it's still completely measurable. I mean, they are quite big effects, these, in the sense that for the satellite navigation system, for example, GPS, the clocks on the satellites tick at a different rate to the clocks on the ground. And it's quite a big effect. I think from memory, it's something like over 30,000 nanoseconds per day difference, because of they're in a weaker gravitational field and they're moving and all sorts of things. It's the same thing. But 30,000 nanoseconds, no time at all. So that's the way that Einstein's theory is built. So he asked the question when he was younger, famously, what would the universe look like if I travelled alongside a beam of light? And the answer is that you wouldn't perceive any time.
Wow.
You can't. The last thing I'll say is that if you've got any mass at all, you can't do that. You can't go at the speed of light. So according to our model, which is a good model and it seems to work, but if you've got no mass, you go at the speed of light. So if you're a photon, you go at the speed of light, and no time.